Okay, picking up, again, it's worth saying because so frequently, once we learn about integrating using logarithms, it is only the form 1 over linear or constant over linear. It doesn't have to be a 1 in the numerator. It has to be a constant. Constant over linear du integrates to the natural log. That is all. I will have so many people tell me that the integral of 1 over u to the fourth is the natural log of u to the fourth, and that's just wrong, and you lose so many points. That's not a minor error, that is a major error. The only thing that integrates to the natural log is 1, doesn't have to be 1, but a constant over linear, constant over u du. And you are allowed to use this fact, that if you see, and we'll zoom in on that a little bit, if you recognize that you have 1 over linear or constant over linear, you don't have to show me the u substitution, because we've talked about this so much. The effect of that slope when you're doing linear, when you have linear arguments, and this is a linear argument inside that basic form of 1 over u du. You have a linear argument. We've talked about it repeatedly, that the effect of that slope is that we are going to divide by it when we are integrating. So you do not have to do a u substitution on this for me. You can use that fact. And that'll creep up quite a bit when you get to Calculus 2. And so, maybe your Calculus 2 teacher will want it. For me, you can just use that fact, because that's what it really I'm trying to do is drive home 1 over linear, constant over u, 1 over u du. Those are the only things that integrate to a natural log, things that you can make into the form 1 over u du. Okay, so let's move on. And so next problem. The trig that you know so far, as far as integrating, is right there. You know sine and cosine, you know cosecant squared, secant squared, cosecant cotangent, secant tangent. That's the trig you know so far. So you don't know the integral of tangent, the integral of cotangent, the integral of secant, or the integral of cosecant. You don't know those. We're going to learn them. So the integral of tangent. Well, as it stands like that, the only thing I could think to do for this is some trigonometry. That's sine x over cosine x, and so now it's a fraction. And what's going to work frequently, but not always, is try letting u equal the denominator to try to get 1 over u du. Because I know that. I know how to integrate 1 over u du. So frequently in fractions, again, not always, there just isn't going to be an always when we integrate. But what will frequently work in fractions is trying to let u equal the denominator to try to achieve 1 over u du. So that's what we'll try. So we'll let u equal cosine x. And then we're going to calculate du. And remember, that's just du, the derivative dx. And so du will be negative sine x dx. And then start making these little checks. Do I have the variable stuff of du? Is it sitting in the problem? The variable stuff of du here is sine x. There's a sine x sitting in the problem, so this is going to work. And so start making those quick checks. That am I on the right track? Do I have the variable stuff of du? Is that in the problem? The variable stuff of du, sine x sit in the problem. The negative will take care of itself. Solve for dx. So dx is going to be negative du over sine x. Then make my substitutions. So the cosine x is going to be u. dx is going to be replaced by negative du over sine x. We get good canceling there. The negative can come all the way out to the front, and I have created 1 over u du. Step 5, unnecessary. We will eventually get to it. We have one variable. So step 6, integrating that, and that equals then the natural log of the absolute value of u plus c. Then back to the original variable. U was equal to cosine x, and so we get negative the natural log of the absolute value of cosine x plus c. And there is a perfectly acceptable answer to what the integral of tangent is. Now, we can play around with this a little bit. So simplifying a little bit, that would be negative 1 times the natural log of cosine x plus c. Just being real specific what that negative was. Then properties of logarithms. Recall r natural log of p is natural log of p to the r. That coefficient can come up and become an exponent. So that's natural log of the absolute value of cosine to the negative 1 plus c. Well, that would be 1 over the absolute value of cosine plus c. Which would be the natural log of the absolute value of secant x plus c. Both of these are completely acceptable answers. And so what I suggest you do, now you could figure out the integral of cosine, the integral of tangent every time you need it, you could figure it out. But I actually suggest that you memorize, and it'll be on the next page, so I won't write it down here, but you just memorize that the integral of tangent is either the natural log, the negative the natural log of the absolute value of cosine x plus c, or the natural log of secant x plus c. You can use either one. My experience with MyLab Math is it will accept both. I almost always go with this one because that way I just don't have to worry about that negative sign. That's the only reason really why people go with this one, because you don't have to worry about forgetting the negative sign. So there's the integral of tangent, done with a u substitution. And like I said, you can figure it out each and every time you need it, but it's way better just to memorize it. It's going to creep up over and over again. And so just like you memorize that the derivative of tangent is secant squared, memorize that the integral of tangent is the natural log of the absolute value of secant. So there's tangent. Okay, secant. And so you might be tempted to do the same thing here we did here, rewrite it in terms of sine over cosine, or in terms of sine and cosine. But here, this is just 1 over cosine. And so imagine, if you will, if it was just 1 over cosine, so that was a 1 up there, if I let u equal, actually we'll show it, you know, if we trying that that's 1 over cosine x dx, and then u equal cosine x, du equal then negative sine x dx. That's not in the problem. So not working. And so this method won't do it. And that was worth saying, that remember, we want to run that quick check, that when you make your choice for u and you calculate du, you want to see that variable stuff in the problem, and it's not, so it's not working. And that's what we're going to go with in Calculus 1. Yes, there are some odd problems where you can do some fudging. You can manipulate things, writing things here and there and whatnot, and you can manipulate it. But as a general rule in Calculus 1, if that variable part of du is not in the problem, it's not working. So what we're going to do instead, and no one would expect you to know this, I'm going to do this. I'm going to multiply numerator denominator by secant x plus tangent x over 1. Or secant x plus tangent x over secant x plus tangent x. That's just a version of 1, and so that's perfectly fine. And so then that's going to give me secant squared x plus secant x tangent x over secant x plus tangent x dx. Now, why on earth would I do that? Besides the fact that it is going to work. And I certainly didn't think of this on my own. Someone taught it to me. I'm going to let u equal the denominator, which then makes du secant x tangent x plus secant squared x dx. Just barely got it on there. And look, that isn't the problem. It's in a reverse order, but it's in the problem. And so that makes dx du, and I will just turn it around now because I can. That's in the problem, and so this is going to work. All of that's going to be u. Dx is going to be replaced by du over secant squared x, secant x plus tangent x. I've got perfect canceling. And so I have 1 over u du, which integrates the natural log of the absolute value of u, and so the natural log of the absolute value of secant x plus tangent x plus c. And so there's the integral of secant. And again, just memorize it, because you're not going to remember this little trick here of how to get it. And you don't need to remember this little trick here of how to get it. Memorize it. And so now there are similar ways you can find the integral of cotangent and cosecant. So please just memorize that the integral of tangent mx, and again, the effect of those linear arguments is to divide by that slope. The integral of tangent mx is either 1 over m secant mx, 1 over m natural log of secant mx plus c, or negative 1 over m natural log of cosine mx plus c. Cotangent mx is 1 over m natural log of sine mx plus c. Secant mx, 1 over m natural log of the absolute value of secant mx plus tangent mx plus c. And cosecant mx, negative 1 over m natural log of cosecant mx plus cotangent mx plus c. Just memorize them. You don't want to have to figure them out every time they creep up. Memorize them. Especially, you're not going to remember the tricks. Or maybe you will, but most of you aren't going to remember the tricks to doing secant and cosecant. So memorize those. Okay, let's end this video and start with the new one on the next video.